Thank you for another seminar, coming to another seminar. Today we have our visiting professor speaking today about some of his research, Professor Wang, or Wang Long if you're in China. I learned that, at least on the trip. Today he'll be speaking about some of the research that he has on compaction of base materials and fabricating equipment. So he's been practicing very hard for this presentation all year, right? Yeah. And just a reminder to everybody that next week we don't have a seminar. There's some kind of class here. That means no free pizza. And then 2 weeks from now, there's the last seminar that we'll have for the April seminar. That'll be with Ryan Smith and Eric Farabee on tollway sustainability. So let's welcome Professor Wang today.
Okay, thank you. Thank you, Professor Rusla, to introduce me to you, and thank you, the Professor Tutumula, give me a chance to come UIUC as a visitor scholar, and thank you, Kent Seminar, give a chance to stand here and introduce some research work. Okay, this is my presentation name. It is my project content. Yeah. It is about rod-based material vibration compaction standard research and fabricating equipment development. This is the map of China. Our university located in here at the north of China. It is the big city of the northeast China. But it's very cold. Colder than here. Yeah. Oh, the professors have been there. Oh, several times. Yeah. This is the landmark building of our university. Our university is famous for aerospace engineering, not transportation engineering. Okay. This is my presentation outline. First, as a background and the research content, and the second, the standard laboratory compaction parameters, and the third is semi-stabilized aggregates, physical and mechanical index relationship, and the fourth is fabrication, compaction standard and equipment design. Five is laboratory compaction monitoring test. Yeah. Background and research content. In lab, we use modified product compacting MPC method to determine the optimum mixture content and maximum joint density. And use pressure machine to formicate mechanical specimen. But on work site, we use vibrating ruler to compaction both base material. There are no contact between between the lab and the lab test and the work site because the compaction mechanism is different. We use different kind of ruler from light to heavy. We know the density is increased greatly with the ruler heavy, and the moisture will gradually reduced. We use the maximum of the MPC method to evaluate on a toilet field compaction. We will find that the compaction degree generally over 100%. That indicates that the lab MPC method, I think, is low. It's low. This is the degradation of the gradation. Use different methods. is as a MPC method, as a VC method, we find that the broken rate of use MPC method as greater than use VC method, especially the aggregate crush value is high. So this degradation will be lead to distorted compaction criteria and make road-based low-year compaction quality inaccurately elevated. So what we can do, we should change the fabricated methods to overcome this problem. Research content. First, as the research on the influence of vibration parameters, frequency, and centrifugal force, nominal amplitude to the aggregate space material property, and put forward the best vibration parameters, and use two kind of methods to fabricate specimen of the same stabilized material and do contrast test, and put forward the conversion relationship of two methods. According to the degree of compaction equivalence principle, we put forward the determined of the vibrating compaction standard and design the equipment. The fourth is use sensors to monitor the responses of the vibration. Optimum or vibration compaction parameters. We designed a machine. It has broad parameters, frequency from 20 Hz to 60 Hz, and centrifugal force from 2 kilonewton to 20 kilonewton, and the amplitude is from 0.01 to 5 millimeter. We used vibration strings to compaction process compaction ability. It means the energy output from the equipment or unit time. It is the equation. It is the equation. We use the three kind of gradations: coarse, medium, and fine. Those gradation covered the gradation that we often used in construction. This is the figure of the gradation. We can use the 108 parameters combination, different kind of frequency and other parameters, and every space vibrating 2 minutes, and we get the drain density and the CBR, and to evaluate the compaction methods. From this figure, we can find there are a peak to every force, filtration force, and the CBR is also same as this one. We can from those pictures to get the best amplitude and compaction force. Another parameter is the vibrating time. How long we keep it vibrating. This picture is the vibrating time and space deformation during the compaction. We find about 85% of deformation occur first 2 minutes, and after 3 minutes, deformation could go to stationary state. So we take 3 minutes as the optimum vibration time. From the result, test result, we can get the best compaction parameters, 3 gradations, and have 3 different kind of best compaction parameters. We see it is a fine gradation. We need a long time to compact it, and centrifugal force will be as high. There are 3 kinds of best parameters, but when we use it, it is not convenience. So we combine it together, put out one best parameters. So we consider the gradations, optimum parameters, and the fine aggregate content and vibrating states. This figure is amplitude and at the relation of this density to the amplitude. We can find if the amplitude larger than 0.6, the density is good, is bad. And this is the VS vibrating strings and the density relationship. If the vibrating strings is greater than 2.2, we can find the density is bad, and greater than 3.5, and the result is ideal. So we, according to the threshold of the vibration parameter, we get the best parameter range. From this range, one can get the best vibrating parameters. Because in China, we often use this type of gradation to construct the base. The passing of the 4.75 about 30 or 38, and the natural force of the material, like gravel, the natural frequency of the material, like gravel, is 33 and 39. If the material's natural frequency equal to the vibrating frequency, the compaction is best. Yes, it's best. So we take this frequency as the best frequency, and the another parameter is time. We take the 3 minutes, and this chart is the bond and unbound aggregate space material, the best compaction measures. It's a component of the 3 kinds of best parameters. The relationship of semi-standardized aggregates, physical and mechanical index. We use the best compaction method to do this test. We use 3 gradations come from the Chinese specification of the design highway asphalt pavement. Use 5 Siemens dosage and 3 compaction degree. There are a lot of test work. The relationship of moisture, we can find it is linear, but a different kind of gradation, it is different. When the gradation is scattering void, the moisture of VC is less than the MPC, and the gradation as become the fine, like the suspended dense, it is will need more moist. This is the relationship of maximum dry density. It is also have a linear relationship. We can find that the density increased 1.8% also, and the different gradation and the increase was different. We find VC method not only can fully compact to different type of gradation, and also can reflect the difference of the different type of gradation. Fabricating method as good or bad, I think should not be measured by the dry density. It can be fully reflect gradations correct. But in China, some people do this test. They said that the maximum drain density as bad is process as good. I don't think so. This is the relationship of the UCS. You know, density is a great influence to the UCS. So we do this test under two conditions. One is respectively by the optimum moisture content and the maximum dry density to fabricate construct specimens, and another is in the same density and the same moisture to do this test. This is condition one result. We can find which specimen will UCS will is increased about 18%.
Can you what SPC again? I got lost. SPC.
SPC. Oh, SPC. Oh, SPC is
Static compaction.
Static price compaction. Yeah, it is a method, the mechanical specimen methods. Yes, yeah. But when you know the density is different, there are effects of the maximum dry density. Another condition is the same. The UCS will be increased 60%. But you know, where come from the additional compression strength? Come from where? I think it comes from the frequency effects of the skeleton. That illustrates that vibration compaction could not happen to ample structure or materials, and can give fully play of the gradation effects. This is the regression of the compressive strength according to gradation type. We can find the relationship as the linear. But this figure is the equation slope and the intercept. This figure we can see which kind of gradation is more suitable for vibratory compaction. Skeleton weld, the slope is high because there are more cost aggregates. So I think it is more suitable for the vibrating compression. The intercept skeleton dense is big, because I think it is a gradation merit in strings. Vibratory compaction method can fully reflect strings of distribution of characters of different type of gradation and make the test result accurately. This is a regression according to the compaction degree. Also, as there are linear relationship. This figure is the compaction degree and the slope and intercept. We can find when the compaction degree is 98%, it is big. I think that when compaction degree is 98, the material can be compacted to the dense and the particle not break. And compaction degree is 19.6, and the compaction degree is insufficient. And when the compaction degree is over 100%, I think a part of particle will be crushed. So the slope will be down. So we can improve the compaction degree to get the high UCS. But I think the fabricating method is more important than compaction degree, because compaction degree over 100, I think the strength will be low. Will be low. This is the integrated regression. There are linear relationship. The space of the VC method and UCS increased about 6-7% than that of the SFC method. We have done the splitting strings text in condition 1. We can find the splitting strings will, as I can prove, 47%. This is the different maximum drag density. The section 2, the condition 2 is the same drag density. We can find that the splitting stress is improved 40%. Vibratory compaction method, I think, have a superiority to form the horizontal structure of the semi-stabilism aggregates. UCS, I think, as a bag, I think it is improved vertical structure of the specimen. This is improved horizontal structure of the specimen. It is integrated regression. It is a relationship as a linear and improved 44% of averagely. We have done some tests of the modulus at condition 1. There are linear relationship. We can find that modulus will as improved only 5.5, very small. We can see they are in the same state. Vibration compaction standard and equipment. There are two aspects of the compaction standard we need to do. One is the standard compaction method. It is means how to determine the drag density. And another is compaction standard of compaction degree. It is a requirement of the according to the lawyers. There are also three factors we need to consider. One is the compaction method should be reflect the material's compaction characters, and another is the requirement of the mechanical property of each lawyer implement design, such as modulus. Yeah. The third is the compaction ability of the ruler. If we put forward the compaction degree as high, but the ruler couldn't compact it to that requirement. It is not good. In Chinese highway asphalt pavement design specification, there are such sentence. Because variatory or large energy ruler be used, the degree of the compaction should improve 1 to 0.%. It means the current highway compaction standard, it is in China standard. It is same as the MPC. Don't match the construction compactability, and the level compacting standard is low. This is the density get from the construction section. This is vibratory ruler result. This is the MPC result. We can find only 5 section MPC result as big than the vibrating ruler result, because the fifth is limestone and the aggregate is weak. There are a lot of particles be unpacked to small space, broken. Aggregate is broken. How to solve this problem? Because we use this method, drive maximum density to control the compaction quantity, but over 100. Or the result is over 100. So we need establishment of standard compaction method. We use the best parameters we have put forward and fix these parameters into a vibratory equivalent. And there are 3 principles to establishment of compaction standard. One is the density equivalence principle, and another is the strength equivalence principle. And the third is the compaction degree equivalence. We use a third method, namely keep the compaction degree requirement of MPC method, just adjust to use vibratory method to determine maximum drain density, and achieve the lab test same as the construction work site. This figure is the compaction degree calculate and different maximum drain density. This is used MPC method. We can find the compaction degree between 98 and to 103%. 98% of the data are over 100, and the average is as 101 and 0.3. Use VC method, we can find the compaction degree is between 96 to 102, and 90% of data is between this range. The average is 98.8%. The difference of 2 methods we can find is 2.5%. When the compaction degree is the same, when we use the VC method, we essentially the compaction degree is increased about 3%. So we put forward the compaction degree of this method. The compaction degree is the same than before, but because the maximum density is big, is larger, so in fact the compaction requirements are improved. This is the design of the standard vibration compaction instrument. There are 3 parts. One is the vibrating part, this part, and another is guiding and elevating device, and the third is a control section. We can control the vibration time and the specimen height, because if we do some strings, we need the same height of the specimen. Technology advantage: this equipment simulating the vibratory or compaction worksite, and parameters are fixed in it, and the vibrating state is stable, and general mode can use it. You didn't need to manufacture special modes. The base material vibrating compaction monitoring test. We know if the material is different, we compact. The feedback is different. In order to know the actual working amplitude and the actual compaction force, we need to do some monitoring tests. We use the accelerometer and LVDT and the bridge to monitor accelerate displacement. This displacement is the space displacement when vibrating, and compacting force. This is the monitor result. This is the accelerate. This is the displacement. This is the vibration beginning. This is the end. This is the actual compacting force. This figure has put 3 signals in one figure. We can find accelerate peak and displacement peak and the force peak take place in same time. Use the result we get the signal, we can calculate the deformation and the actual compacting force. The influence of the material stiffness on vibration state. We use the flash to study it. Moisture content is different and the stiffness is different. The vibration state is different, and the material is soft. There are no bonds. The compaction is very stable, and if the material is harder, 2 circle or 1 bonds, there will begin to bonds, and the material become more hard. There will 3 circle 1 bonds. This is the parameter index of the vibration compaction as compaction. When the flux edge is stiffness as increase, the acceleration amplitude increase, and the actual actual compacting force are increased, and actual amplitude are increased. The harmonic component from no to more. That indicates that essence of the vibration compaction as the result of the vibration and impacting. This is the distribution of the compacting force. We can find compacting force is real-time changing. The distribution is a normal distribution. We can we can say that vibratory compaction can be regarded as that material can be compacted in a variety of compacting force. This is the different kind of road material plastic deformation we get. When the vibration time is over 5 minutes, 50 seconds, the vibration state becomes stable. We use the linear equation to regression it. We use the slope to calculate CI parameter. It is use it to evolution compactability of different kind of material. It means the required compacting stress produce unit displacement. It is the result of CI. We can find the root material compactability can divide into 3 levels. One is the difficulty to compact it, such as the asphalt mixture. The CI is around 770, and another is can be compact, such as the base material. It is level 2, and the third is easy to compact it. This is lime and plus a flash. It is a bond material. The CI is about 300. Summary. Through the research, we find different kind of structure aggregates have different optimum fabricating methods, and according to compact characters of the and energy protects, we put forward optimum vibration compaction parameters. And the physical and mechanical index relationship of two kind of methods are linear, and we see space mixture density is improved 2 and to 3%, and the MPC and the UCS or MPC method is improved 67%, and the splending strength can be improved 44%, and the modulus is almost in the same state. VC method can reflect different physical and mechanical properties of the gradation. It can refine the design of the materials. And essence of the vibration compaction as the comprehensive effects of the vibrating and impact. The actual compacting force are normal distributed. Okay, it is all. Thank you.
Questions, Professor?
No.
Thank you very much for your presentation. your presentation a little better. So I think I get the essence of your presentation. Granular materials properly, compacted through vibratory action in the lab would probably agree more